Alright, we're going to look today at using the quadratic formula and the discriminant. Several of you have probably done this before. That's great. Should be a little bit of review and hopefully something a little bit new and insightful. So our two objectives are to use the quadratic formula to solve quadratic equations and to use the the discriminant to make decisions about quadratic equations. Here we go. Alright. So first off, let's just look at what the quadratic formula is. Given the quadratic equation, we have a number times x squared plus a number times x plus c, which is a third number, equals 0. Its solutions are given by the equation here. Okay, negative b plus or minus x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You need to have this memorized. Okay, there are plenty of songs. We'll sing a few of them in class. Mnemonics, whatever you can do to memorize it. We're going to have at least one, if not two, quizzes where I'm just going to simply ask you to write it down. That's it. Okay, you need to have this memorized. I don't know how many ways I can say that. All right, so I first of all want to go through a proof of it with you. This is not something I need you to write down. I want you to see it though. If you like it, if it's something that's interesting to you, go ahead and write it down. But if not, then just go ahead and follow along. So the first thing we do to find out what the quadratic formula is, we divide everything by a. Okay, so the a goes away. A divided by a is 1, b divided by a, c divided by a, and 0 divided by a is 0. Okay, we move the c over a to the right-hand side by subtracting c over a from both sides. I get x squared plus b over ax equals negative c over a. Then I complete the square, because the section we just did. So I take this term, the b over a times x, I take the b over a, I divide it by 2, that gives us b over 2a, and I square it. And I add that number to both sides. That's completing the square. We've just done that. Finally, because I've completed the square, I can write the left-hand side as x plus b over 2a all squared, that's what completing the square does, equals the right-hand side, which is negative c over a plus b over 2a squared, and I can square each term. B squared divided by 4, which is 2 squared, times a squared. So I'm going to do two things now. Well, first of all, I'm going to simplify the right-hand side by combining into one fraction. So I multiply this fraction here by 4a so that I get a common denominator. I get 4ac here, okay, and I get 4a times a, which is 4a squared. And now I've done that so I have a common denominator of 4a squared. Okay, so I combine into one fraction negative 4ac, because that negative right there, plus b squared all over 4a squared. And I'm just going to rewrite, so I have b squared minus 4ac over 4a squared. Okay. If we continue on the next page, that's what I had written down previously. I square root both sides, and I get x plus b over a equals plus or minus, because I take a square root, the square root of the right-hand side. And I can simplify a little bit more now. I can subtract b over 2a from both sides. I solve the square root. And then finally, I can simplify the denominator here, because the square root of a whole fraction is the same as the square root of the numerator divided by the square root of the denominator. And the square root of 4a squared is 2a. Now I have a common denominator, and there's our quadratic formula. Okay, so this is how it comes about. It's not magic, it's just completing the square, although the algebra is pretty messy. Okay, let's look at a problem. What I want to do is I want to solve this equation. I want to find all of the values of x for which this is true. Okay, so I'm going to use the quadratic equation to do that. In order to do that, I have to have it in the form ax squared plus bx plus c equals 0. Now I have ax squared plus bx plus c equals 0. Now my a is 1, my b is 3, and my c is negative 2. Okay, and now I can plug into my quadratic formula. Negative b, so negative 3 plus or minus the square root of b squared minus 4 times a times c all over 2a. Now, you need to write this out as is every single time. Please don't simplify as you go. Please plug in explicitly like this with the parentheses and everything. So on your homework, on your exams, I should see you writing out x equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 2 with the parentheses in there and not simplified. So please do that first. Write it out even with 2 times 1 on the bottom. Now simplify. I get negative 3 plus or minus the square root of 9 plus 8 over 2. And that's x equals negative 3 plus or minus the square root of 17. And 17 is prime, so there's nothing I can do there. All over 2. And so I have two solutions. I have negative 3 plus 17, root 17 over 2, and negative 3 minus root 17 over 2. And you'll notice the graph of x squared plus 3x minus 2 is given right here. And you'll notice it hits the x-axis once here. Okay, that's the negative 3 minus root 17 over 2. And it hits the x-axis here. That's the negative 3 plus root 17 over 2. So it has two places where it hits the x-axis. We have two solutions. Let's look at another example. We're going to solve this equation, which is quadratic, but it's not in the right form yet, so I have to set it so that I have everything on the left and 0 on the right. That's going to be simplified there. If I subtract 12x from both sides, I get negative 30. If I add 9 to both sides, I get plus 9. So my a is 25, my b is negative 30, and my c is 9. If I plug in, this is what I get. Negative b, so negative of negative 30 is positive 30. I wrote that plus there intentionally. Plus or minus, and again, I just plugged in. B squared, negative 30 all squared, I'm using my parentheses appropriately, minus 4 times a, using parentheses, times c, using parentheses, all over 2 times 25. So, negative 30 squared is 30 times 30, which is 900. 4 times 25 is 100, times 9 is 900. So under the radical here, I have 900 times minus 900, which is 0. And that's all over 50. So I get 30 plus or minus 0 over 50. Well, that's 30 over 50, which is 3/5. So notice there's not a plus or minus left. The plus or minus is gone, so I have one solution. X equals 3/5. And if I notice, here's the graph of 25x squared minus 30x plus 9 equals 0. So it says, where does this equal 0? Is what we just solved. Well, it only touches the x-axis at one time. Comes down, boom, and goes right back up. Okay, so I only have one x-intercept. Here's the last example. I want to solve this equation. Negative x squared plus 4x equals 5. Okay, so I'm going to bring the 5 to the other side, so I get negative x squared plus 4x minus 5 equals 0. A is negative 1, b is 4, c is negative 5. Plug in. Negative b plus or minus b square root of b squared minus 4 times a times c all over 2 times a. Simplify. Negative 4 plus or minus the square root of 16 minus 20 all over negative 2. So notice here I get negative 4 plus or minus the square root of negative 4 as well, all over negative 2. This is the square root of a negative number. Now we've just learned about complex numbers, so we know we can simplify that further. I can rewrite this as negative 4 plus or minus I times positive root 4, which is 2. So x equals negative 4 plus or minus I root 4 all over negative 2, which is the same as negative 4 plus or minus 2i all over negative 2. Now, I can divide this into two fractions. Negative 4 divided by negative 2 plus or minus 2i divided by negative 2. So I get negative 2 plus or minus I. So I get negative 2 plus I or negative 2 minus I. Now, these are both complex numbers. I cannot graph them on the real plane. I have to use complex numbers to graph. So if we look at this here, the graph of this equation never hits the x-axis. These are imaginary or complex solutions. There are no real solutions, no numbers in the number line where this works. Okay, so we have three basic kinds of problems. We have the solution where we had, there it is, two real solutions. We had the situation where we had one real solution, and we had the situation where we had two imaginary solutions, or no real solutions. Okay, so let's talk about let's try to quantify that a little bit. Let's try to make that into a statement. Now let's look at something called the discriminant. The discriminant is the part of the quadratic equation underneath the radical, underneath the square root. So the discriminant is b squared minus 4ac. And one great thing about the discriminant is if you can evaluate the discriminant, you've learned something very important about the quadratic equation. Here are the observations. If that discriminant is positive, I end up taking a square root of it. And when you take a square root, in this case, you put the plus or minus there, which means I get plus or minus. So I get two solutions, two real solutions. When this number, the discriminant, is positive, I know I'm guaranteed that the quadratic equation passes through the x-axis twice. The graph crosses the x-axis twice. When the discriminant is equal to 0, that is, I'm not taking a square root of anything, okay? I'm guaranteed one real solution. It only touches the x-axis, and that's because when I take plus or minus the square root, there is nothing to take a plus or minus of. So that's gone. There's no plus or minus, so that means that we're down to one solution. If the discriminant is negative, we get two imaginary solutions. That's to say, we don't get any real solutions. The graph never crosses the x-axis. So now, the question might be, well, why would you care? Well, sometimes you might be working on a hard problem and you say, gosh, I hope this really works. I hope I can actually come up with an answer to this. I hope I can actually show that there is a real answer. Okay, because sometimes you only want real solutions and not imaginary solutions. In the case where you need a real solution, sometimes checking the discriminant is a lot faster than going through the entire quadratic equation. Here's some examples what I mean. This one is, does the equation have any real solutions? If so, how many? I'm not asking what they are, I'm simply saying, can we figure out if it has any solutions? So all we have to do is evaluate b squared minus 4ac. Okay, so b is negative 8, a is 1, and c is 16. So 8 squared is, negative 8 squared is 64, positive 64 minus 4 times 16. Oh, it's also 64, right? Okay, so what do we get? We get 0. So this discriminant is equal to 0. So we get one real solution. Okay, so if somebody asks you to solve this problem and say, gosh, I don't even know if it's possible, you can say it is possible to solve. That's what's nice about it. How about this one? Does this have any real solutions? If so, how many? Okay, so again, we check b squared, which is negative 8 squared, minus 4 times a times c. Okay, that's 64. That's, okay, 4 times 15 is 60. So I have 60 minus, is this positive or negative? Oh, 64 minus 60 is positive. That's all we care about, okay, in this particular case. So does it have any real solutions? It does. It has two. It crosses the x-axis twice. Okay? All right, so that's all we got for today. Talking about, again, quadratic equation, how to use it to solve a quadratic equation, or sorry, the quadratic formula to use to solve the quadratic equations, and how we might use the discriminant to determine how many solutions there are. Okay, thanks everybody.